Hey team, how are we going? Man, I feel for the level ones. I do feel for the level ones. Because, like, just trying to come up with questions for them is just so hard. And it's... Yeah. Anyway. Differentiation. Yay. 24th. Should we do a question that we haven't actually covered in this lot before? Let me just go pick up another question. Oh, Roars, come on. Even if you watch the playlist, you should still be fine with those questions. YouTube, where are you? Okay, resources. 578. Should have started before Mox. Let's go 2015. Just once. I don't know what the exam paper... We're going to do 2015 just because the last kind of couple of questions that we picked up from thing were quite nasty. Lolita, it is called an excellence stream, so we'll definitely be doing an excellence question. Just bear with me. I just need to find a question that is horrible enough for us to do. How about a chain rule? A triple threat chain rule. Or... I got 2 triple threat chain rules. Why is this not loading up? Differentiation. I'm in differentiation, man. Come on. Sync notebook. Sync notebook. Jesse, no, we're going to work through a couple of excellence questions, but like, trust me, these excellence questions are not that hard. Like, I actually feel like these are the easy excellence questions. Let me just pick up. Oh no, that one's a bit. Okay, let's try this one. I think we've done this one before slightly. I get a feeling we've done this before in one of the papers, but we'll do it again. And come on, why is my thing not syncing? Sync. Technical difficulties, a lot of technical difficulties today. Lohita, I think the techniques are just practice. Roars, yeah, D&D is good. My past exam papers are good, and my past tutorials are good as well because we kind of cover a lot of things together. Yeah, Aqua, it's been a bit frustrating today because... Oh, what? It has synced. It's just in the wrong place. I'm an idiot. All right, there we go. That's better. Okay, I'm going to copy this question and then we should be good to go. No, there was no technical issues. There was just human error this time. All right, here comes the question. I'll actually put it up here so... Where is it? Where is it? Where is it? Too many screens. Too many screens. We're good. Okay, so... Now, for this question, I'm going to be honest with you. All you really need to know is some basic differentiation. And then we should be good to go. This is a triple threat chain rule. I'm going to tell you this right now. So yeah, so let me give you a couple of minutes to have a kind of go at it. And then what I'll do is I'll open up with a couple of hints. and then we will kind of work through it. Is Ezra actually here, James? Or how can I say that if Ezra's not here? Ah, Sienna is back here. Hello, Sienna, and hello, Lolliot. I see all the other guys are like, no, we can. See, this is funny because all you guys ask for excellence daily, and then you guys don't show up. Even is Lauren actually here today, or is she gone quiet? Yeah, see, Lauren's not here. Oh, happy birthday, Ezra! Happy birthday. Yeah, I know, awesome, because I know you're always there quietly at the back. Music at his back as well. Ah, yeah, no, Blake's always here. True. TJ. Oh no, TJ doesn't come on Thursdays because I think he's got something on. Nah, all good, Sienna. All good. All right, so hint, or are we good to go? I gave you the first hint, which was triple threat rules. And then we'll go from there. It's alright, Alton. I mean, geez. Check the schedule on YouTube, Aqua. Honestly, I can't. I've done like 10 tutorials this week. Do we do tutoring? No, I don't do tutoring, Aqua. I might do it in maybe a few years' time, but not yet. I have a grand plan to quit teaching. All right, so let's start going through this question because I do have to kind of get some shut-eye tonight because I'm planning a heist tomorrow for my Mac, for my form class, as you call it. Now, Rose, I don't think you need to watch 15. I think you'll be all right with this because this is just rate of change question, Rose. So we're going to start doing this. At the moment, like the way I always do these questions is I write down what I have and then I write down what the question's asking for and then I come up with a formula. 3 steps. Write down what you have, write down what the question's asking for, and then third step is come up with a formula. Okay, so let's have a look. First line, yeah, nothing useful there except it forms a cone. Slant of the cone is 30 degrees. Okay, so let's start writing some letters here. We've got H. Slant height, I'm going to put that as S. Then it says conveyor belt delivers salt at a rate of 2 meter cubed per minute. Now, the key thing is here. We've got 2 meter cubed and we've got per minute. This is a rate. Meter cube is volume. Per minute is time. So, in other words, we can write this as dV dt equals to 2 because the 2 meter cube is the volume. And the per minute is the time. Oh, look, J. Crow is actually here today. Hello, J. Crow. Welcome, welcome. So we've got that. And then the question is saying, find the rate at which the slant height is increasing when the radius of the cone is 10 meters. All right. So the question is actually asking us to find when is the slant height, the rate at which the slant height is increasing. So basically, the question is asking us slant height and rate. That means the question is, what is ds dt when r equals to 10 meters? So like I said to you, step 1, what do you have? Step 2, what is the question asking for? Step 3, figure out the equation with everything you have. So we're looking for ds dt. Well, this is what we're looking for. What we have is we've got dv dt. We also know the shape that we're working with is a cone. So because we're working with the shape of a cone, we need the formula for cone. Volume of cone, off the top of my head, I've got no idea. I can't remember it. 1/3. There we go. 1/3. 1/3 pi r squared h. All right. So that's one of the things. Now, the problem with differentiating volume of the cone is I've actually got two variables. I've got r, and I've also got the height. So I need to get rid of the height. Now, the good thing is the height and the r, there is a link. Because if you think about it, this is the height of the cone, which is h. And this is the radius of the cone. And you can see that it has got a 30 degrees in there. So potentially, I can actually rewrite, get rid of h and write it in terms of r. So to do that, I've got opposite and adjacent. So I'm just going to copy this down here. So h, r, and 30 degrees. So this is opposite and adjacent. So what I've got here is tan 30 equals opposite over adjacent. So that is h over r equals tan 30, and then h equals r tan 30. So what I can then do is I can write volume of cone as 1/3 pi r squared times r tan 30. I'm not going to calculate tan 30, I'm just going to leave it as it is. But because I have r here, when I differentiate the volume of cone, I am going to get dv dr. Now, going back to step 3, I don't have a dv on the left-hand side of my equation. I've only got ds dt. So I've got to get rid of the dv. The only other thing that I've figured out so far is dv dr. So as you can see, the dv dr, once I figure it out, I need to turn it upside down so I can replace it as dr dv. But the thing is, you've got dv and dv disappearing. We now need to get rid of the dr. But we also need s. So if you look at it, we need s in terms of r. So to do s in terms of r, we go back to the little triangle in the cone. Because here, s is the hypotenuse. And if I want to connect s and r, I'm going to get cos. So cos 30 degrees equals adjacent over hypotenuse. So then I'm going to get r over s equals cos 30. And I can actually write this as s is equal to r over cos 30. Because when I differentiate this, I'm going to get ds dr. So I can bring that back into my original number 3 line, and I can replace that with ds dr. And what happens is the dr's now disappear, and I've got ds in the numerator, and I've got dt in the denominator. And I'm going to pause there just to see if there's any questions. You're on the right track there, Blake. So roars, that is pretty much, you know, this is one of the most, you'll do the basic differentiation in these questions, in the rate of change questions. But all you have to do is just make sure you write the formulas in the right spaces. And after that, it's literally easy as. So we're going to figure out what dv dr is first. So dv dr, that's 1/3 pi r squared. So I'm going to expand it first. Hang on, let me just rewrite this. So volume of the cone equals 1/3 pi r cubed tan 30. So when I differentiate it, I'm going to get dv dr, which equals 3 and 1/3 disappeared. I'm going to get pi r squared tan 30. ds dr is going to be 1 over cos 30. Yep, and then that's pretty much it because we're done. Because look at this, dv dt is 2, dr dv is 1 over pi r squared tan 30, ds dr is 1 over cos 30. Now the question said r is equal to 10, so then we've got 2 times 1 over pi times 10 squared tan 30 times 1 over cos 30, and you are finished with this question. Where is the mouse? So we've got 2. Make sure your calculator is in degrees mode for this because we are working with 30 degrees. So we've got 2 over, I hate this, pi times 10 squared is 100 times cos 30 times tan 30 equals to that. And because this is ds dt, we know that time was in minutes, distance was, in this case, I think it was in meters. So we're going to put in meters per minute. Roars, when you say the 3 playlists, are you talking about the exam papers or are you talking about the playlists, like the 15-hour playlists? Alton, it is, why is it 1 over cos 30? Because it's r times 1 over cos 30. When I differentiate r, I get 1. Cos 30 is a number, so I've just left it as it is. Roars, you got plenty of time, mate. You have plenty of time. Now, I don't think you will lose points, Blake, because the schedule does say correct solution with correct derivatives. It doesn't talk about anything about units. Yeah, thanks, Jot, for the vote of confidence. I appreciate it. Yes, that's great advice from Aquatic Duck. Watch it at 1.5x speed because there are parts where we are like really kind of just chilling out and just kind of talking. Yeah, that's pretty much it, Sienna. Only 18 days left. 9 in a day. Did you watch 9 hours of calculus? Did you just binge it, Alton? If you give your answer in radians, would it still be considered correct? No, I think you'd be incorrect because if your calculator was in radians, like check this out. If I was to do this answer in radians, I mean, obviously I'm going to get a different answer. There you go. There's your problem with radians. It's actually decreasing. The slant height is decreasing. Yeah, 9 to 15, like it covers quite a bit of, like, we try and do like a lot of merit stuff during that time. 8 to 9 in one day. 10 hours. Man, I've never heard this. This is crazy. All right, guys, look, unfortunately, I've got to call it a night today because only reason is because tomorrow I'm doing a whole day activity for my Mac kids, which is like my form class kind of thing, and we're doing a heist in my school, and I need to get up very early in the morning to set up everything. If you ever watch Brooklyn Nine-Nine, you know what I'm talking about. We're basically doing a heist, a Halloween heist, where it's not Halloween heist, but they've got, it's been like, I've been creating it for like nearly 2 months. I've been working on it, but tomorrow it's on. I think I am. I think I am No, I'm not gonna be Captain Holt because to be honest, my crew, like my guys, my class, they're actually an awesome little bunch there. But long story short, I'll tell you what they're gonna do tomorrow, which I can't believe I'm gonna go on record to say this, but it doesn't matter because everybody knows in the school. Basically, I'm putting something in the principal's office, and I'm putting an item in there that they have to go and get it out without getting caught. So they've got a whole bunch of challenges that they have to do throughout the day, and every time they complete a challenge, they get a little colored tag, and they have to come and once they collect enough tags, they come to me and they try and, using the color tags, they have to solve a puzzle, and if they solve the puzzle, they'll get an access code. So, but every time they get caught, the access code changes, and they lose the colored tags as well. So there's only a limited amount of tags that they can use. So I'm looking forward to it. You're throwing tuna around. Jeez, that sounds crazy. Jake Peralta. Yeah, no. We're doing some crazy kind of adventures tomorrow. I can't believe that you guys are finishing on Tuesday. It's just intense. Alton, it took me like the amount of planning I had to do for it to. I think I did more planning for that than I've done for like any kind of lesson prep. Nice, Roars, nice. Oh, streakers, that's just disturbing. All right, guys. Anyway, look, I'm gonna record the whole thing, but like I don't think it's gonna come on my socials. If it makes to my school's socials, you might be able to see it, and if it does, I'll actually post a link that you guys can actually watch it. But it's, yeah, there's water guns involved, there's sabotage, there's backstabbing, but ultimately one team is gonna win it, and yeah, I'm pumped. I'm super pumped about this tomorrow. No worries, Roars. Good luck for it. No, I'm talking Lolliet. I'm talking about, I'm going to document the whole thing, but I can't put it on my socials because it's the school kids. Unless our school social media team decide to put it, then it's all good. Then you guys can actually watch it through the school social page. But yeah, no, I'm looking forward to it. It's got to be pretty crazy. Anyway, thanks guys. I will see you guys Sunday night for integration. All right, take care till then, and yeah, I know some of you are coming down to your last few days of school, so make sure you enjoy it as well. So I didn't realize Labor Day came so late this time, and some of you are finishing like school within a couple of days. For some of you, this is the last Thursday, isn't it? Richie, not really sure, Richie, how I can help you with that. It's just scholarship questions. Yeah, I think Richie is set. Hey, awesome. Are you in Wellington? I forgot to ask because I can't remember off the top of my head now. Because I'm coming to Wellington on Saturday. I'm gonna do a quick drop-by visit. Fair enough. Now there's three things that they're gonna take, but two of them are the real one and one of them is the fake one. So there's so many twists in tomorrow's one. So you'll be fine, Melon. Get through the practice. You'll be fine. All right, guys. Take care. Have a good night, and I will see you Sunday. All right, after my trip to lovely Wellington. Catch you guys.